Hi friends, welcome back to Team Education. Friends, in this video we are solving problem on application of derivatives. Okay, given problem is show that the condition for orthogonality of two curves ax square plus by square is equal to 1 and a1x square plus b1y square is equal to 1 is 1 by a minus 1 by b is equal to 1 by a1 minus 1 by b1. Friends, you observe to solve this problem, first we have to find out the key points. What are the key points they are given? You see. Show that the condition. What condition? Orthogonal condition we have to show. Okay. Of what? Curves. What are the curves here? Ax square plus by square is equal to 1. Consider as a C1 curve. And a1x square plus b1y square is equal to 1 as a second curve. So these two curves are orthogonally intersect. Then we have to show the condition. What is the condition? 1 by a minus 1 by b is equal to 1 by a1 minus 1 by b1. Friends, generally problems what they will do? Show that two curves are intersect orthogonally, or else find the angle between two curves. But in this case what they gave? They are saying C1 and C2 curves are orthogonal. Orthogonal curves means intersect orthogonally at least one point. But here what they given? Ax square plus by square is equal to 1. Are they given ab values? No. Here a1 b1 they are given. So are they given a1 b1 values? No. So we have to consider this a b a1 b1 are any arbitrary constants. Any arbitrary constants. So first, how to prove this condition? Friends, we have a working rule. In the working rule, step 1, what we have to do? Suppose C1 curve and C2 curve is there. So we have to prove orthogonally means these two are curves orthogonally means first we need to find what value? We need to find out intersecting point. So we have to find intersecting point first. It may occurs more than one point, friends. Okay now. Second point, what we need to do? Intersecting point. Suppose if you have P of any point, friends, x1 comma y1. Okay, or maybe if it is intersecting more than one, you can take a q of x2 comma y2. 3 points maybe. Okay, now based on the curve, friends. Okay, you remember. Next, second one, what we need to find? We need to find out the slope of the each curve. So we have to find out m1 for the first curve slope and m2 for the second curve slopes. Okay, now m1 comma m2 slopes. Next, third point, what we have to do? We have to prove orthogonally. What is mean by orthogonal curves? If two curves are intersect orthogonally means it should satisfy the condition m1 into m2 is equal to minus 1. m1 into m2 is equal to minus 1. Then you can say these two curves orthogonally intersecting. Okay now I am going to solve this problem. Friends, here a, b, a1, b1 are arbitrary constant. So first I am going to find step 1 what we have? Intersecting points. So if they are given any constants, any constant means maybe 2, 3, minus 1, minus 4, 1 by 2, 1 by 3 like that. If they given a constant, then we can find out intersecting point directly. We will get a constant. But here they are given arbitrary constant. So what I am considering first, let P is a point x1 comma y1 intersecting C1 comma C2 curves. So obviously if it is intersecting, then you can say a x1 square plus b y1 square is equal to 1 and a1 x1 square plus b1 y1 square is equal to 1. So it should satisfy equation 1 and equation 2. This p of x1 comma y1 point is passing means these two are intersecting at P, suppose. Then what we can say? The curve is satisfying this point or not? Second curve is also satisfying this point or not? So if it is satisfying, then you can write a C1 curve as ax1 square plus by1 square is equal to 1 and a1 x1 square plus b1 y1 square is equal to 1. Now we have to solve these two. If you are solving these two, then you will get a relation between x1 and y1 only. Friends, this AB are not constant. Okay, now AB are not a fixed constant, arbitrary constant. Due to that reason, we will get a relation. Okay, now we have to find those relation for solving x1 and y1. Friends, now we have to find out the intersecting point. For that, we have to solve for x1 and y1. Okay, Friends, here you have two curves. Those two are similar curves. Now here a common term what you have, we need to find x1 square and y1 square. Actually x1 y1 only. Here also you have x1 square y1 square. So friends, to solve this generally, if you want to find out x1 square and y1 square, okay, first you written like this, x1 square and y1 square, and you written 1. Okay, now to find x1 square, generally what we are doing, we have to take these two values only, remember. Okay, you write down friends, if you want to find x1 square value, downside what we have to write, you see, y1 square quotient write down, y1 square quotient what I have, b, next constant what I have, 1, later you write down, after this x1 square quotient what I have, a, okay, next you write down constant, another y1 square quotient is what, b. Okay, similarly I will repeat again friends, if you want to find out x1 square, you remove this, remaining y1 square quotient what I have, b, constant what I have, 1, later x1 square quotient write down, later x1 square, this is which value, x1 square quotient, next you write down y1 square quotient here. Okay, now here also you need to write friends, leave this term, now write down y1 square quotient is b1, next constant what I have, 1, next after this you need to write x1 square quotient, what is x1 square quotient, a1, next y1 square quotient is what, b1. So whichever you are starting, same you have to end also. Okay, now I repeat again, you see friends, first x1 square y1 square 1 you need to write, in the downside of x1 square what you have to write, remove this. Okay, next what I have, y1 square quotient b, write down b, next constant write down, later you write down x1 square quotient and end with the same b. Okay, now later you observe friends, here you have to write x1 square quotient. Now here no, what we have to do, you remove x1 square term, next what I have, y1 square quotient is b1, next constant, next you write down x1 square quotient, later end with the b1. This is the procedure friends. Next x1 square divided by, friends you see, b into 1 minus b1 into 1. Okay, x1 square divided by b into 1 minus b1 into 1, which is equal to y1 square divided by 1 into a1 minus 1 into a, which is equal to 1 divided by a into b1 minus a1 into b. Okay friends, now I will repeat, x1 square divided by b into 1 minus b1 into 1, y1 square divided by 1 into a1 by 1 into a, next 1 divided by a into b1 divided by a1 into b. Now from this what we can say, x1 square by b1, here you observe 1 2 3, 1 is equal to 2, suppose a is equal to b is equal to c if you have, then you can say a is equal to b and a is equal to c also. Yes or no? Right. From this you can say x1 square divided by b minus b1 is equal to 1 by ab1 minus a1b, and y1 square divided by a1 minus a is equal to 1 by ab1 minus a1b. Okay, so x1 square is equal to b minus b1 by ab1 minus a1b, and y1 square is equal to a1 minus a by ab1 minus a1b. Okay friends, and from these two you can also say that x1 square by y1 square is equal to, these two are getting cancelled or not? You see friends, denominator ab1 minus a1b, ab1 minus a1b, both are getting cancelled when you are doing x1 square by y1 square. Then you will have b minus b1 by a1 minus a. Okay, this is the relation in between intersecting points we have. Okay, next in the step 2, what we need to find in the step 2? We need to find slopes of ax square plus by square is equal to 1 and a1x square plus b1y square is equal to 1. Yes or no? So to find the slopes, what we have to do? Differentiate these two equations with respect to x. Okay, differentiating with respect to x, then you will have a into x square derivative is 2x plus b into y square derivative 2y into dy by dx, which is equal to 1 is a constant, so this derivative is 0. Now we need to find out slope means dy by dx value. Now we need to find out dy by dx. For that, first we can write 2by into dy by dx is equal to minus 2ax. Now dy by dx is equal to minus 2ax divided by 2by. From this what we can say? Actually dy by dx we are denoting with what? M, that is equal to dy by dx, which is equal to 2 getting cancelled. Then you will have minus a by b x by y. I am separating the variables and arbitrary constant. Of course you can write minus ax by by. It's not an issue. Okay. Now solve for the second curve slope. Okay. Differentiate this equation with respect to x. Then you will have 2a1x plus 2b1y into dy by dx, which is equal to what? One derivative is 0. So 2b1y into dy by dx is equal to minus 2a1x. Okay. Now dy by dx, which is equal to minus 2a1x by 2b1y. So from this you can say the slope m is equal to dy by dx, which is equal to 2 getting cancelled, minus a1x by b1y. Okay friends, first this is a slope m1 and we can denote this as slope m2. But where we are finding this slope m1 and m2? Intersecting at a p of x1 comma y1. So in this case you can say m1 at p is equal to minus a by b x1 by y1. Next m2 at the point p x1 y1 is minus a1 by b1 into x1 by y1. But what they given? This C1 curve, if you consider this is C1 curve and this is a C2 curve, both points are intersecting at least one, generally intersecting at least one point friends. I am considering one point, that is P of x1 comma y1. So this slope is m1 and this slope is m2. We found a slope m1 at p and m2 at p. Okay, now what we have to prove? Actually, if they are given if we have a constant, to prove orthogonality, but they are saying these two curves are intersect orthogonally. Directly they are given. So friends, in the step 3 what they give? Curves are intersect orthogonally. So what is the condition we have? m1 into m2 is equal to minus 1. Write down what is m1? Minus a by b into x1 by y1. And what is m2? Minus a1 by b1 into x1 by y1, which is equal to what? Minus 1. Friends, you observe minus into minus plus. Here what I can say, constant I am writing one side, that is a1 by b1. Next here you have x1, here you have x1. So x1 square divided by y1 into y1 square, which is equal to minus 1. So we have a relation friends like this. But you have to prove actually what? 1 by a1 minus 1 by b1 is equal to 1 by a minus 1 by b. So you have to remove this x1 square by y1 square. From equation 1, in the step 1 what we have actually? We have x1 square by y1 square, which is equal to b1 minus b by a minus a1 we have. So from these two what we can say? Here you observe friends, I am removing means I am replacing x1 square by y1 square as b1 minus b by a1 minus a. So a1 by b1 into b1 minus b by b1 minus b by a minus a1, which is equal to minus 1. Now actually I am doing a1 terms and b1 terms are separately. Okay, so first I am writing, you see, b1 minus b by b1 I am writing one side. Next take these are left side, so minus of a, this if you are taken right side, then what will happen? Denominator will become a numerator. So a minus a1 divided by, this is in the numerator, so it will become in denominator a1. Okay, now separate the terms, b1 by bb1 minus b by bb1, which is equal to minus of a by a1 minus a1 by a1. Okay friends, now multiply inside. Then here you observe friends, what are the getting cancelled here? b1 and b1 getting cancelled. Now 1 by b, here bb getting cancelled, then 1 by b1 is equal to minus, here a getting cancelled, so minus 1 by a1, minus into minus plus, here a1 getting cancelled. Then you will have 1 by a. Actually what we have to prove? 1 by a. Now you take a1 b1 terms are one side and ab terms are another side. So 1 by a is 1 by a. Here you have a b. Now this b, if you take a left side, what will happen? Minus 1 by b, which is equal to, you take this is left side, then you will have positive 1 by a1. Here you have a minus 1 by b1. So proved or not? Yes. So like this we have to prove. Okay, friends. Right. Thank you for watching this video.